So today we will start with Arden's theorem. So first of all, the definition for Arden's theorem is if P and Q, if P and Q are two regular expressions such that P is not equal to null. Here Arden's theorem says that we have two regular expressions P and Q such that P is not equal to null, right? And the expression has the following equation containing R is equals to Q plus RP has a unique solution given by R is equals to QP star, right? So wherever you find this equation, it will be replaced with its corresponding solution, and the solution is R is equals to QP star, right? Here P cannot be null. P is not equals to null, right? So Arden's application is why we use the concept of Arden's theorem. So whenever a transition system is given to you or an automata is given to you and you have to find out the regular expression, then we will use Arden's theorem, right? Whenever a transition system or a diagram, a transition system is given and you have been asked to find out the regular expression. You have to find out the regular expression, then we will use this Arden's theorem, right? So let's begin with the first example. Consider the transition system. First example is consider the transition system as shown in the diagram. Find out the regular expression. Find out the regular expression. So the diagram which is given to you is the first state is Q1. Q1 upon the processing of A, it is going to itself, and upon the processing of A, it is going to next state, that is Q2. Q2 upon the processing of B, it is going to itself, and upon the processing of B, it is going to Q1. Q2 upon the processing of A, it is going to next state, which is your final state, that is Q3, and Q3 upon the processing of A, it is going to Q2. So this diagram is given to you. Now you have to find out the regular expression. So first of all, you will write as much amount of equations equivalent to the number of states given to you. So here you can see that we have been given with 1, 2 and 3 states. It means that minimum you need 3 equations. It means you minimum need 3 equations, right? and your final answer, your final expression will be in your final state, that is in Q3. So first of all, let me write the equation. So equation for Q1 is, now you will have to check the incoming arrows towards each state. You have to check the incoming arrows. So Q1 upon the processing of A. So first edge is A. So here you need to write Q1 A plus, again B is approaching towards Q1. So from where B is approaching, it is approaching from Q2. So second is Q2B. So Q2B. Next, for initial state, you have to include the null. For initial state, you will have to include the null symbol. Let me divide the board into two parts, right? So let me write the equation again. So Q1 is equals to Q1A plus Q2B plus null, equation number 1. Then the equation for Q2 is equals to, again you need to check the incoming arrows towards that particular state. So upon Q2, three incomings are there. The first is with A. So A is approaching from Q1, Q1A. The second incoming is B. This B is approaching from Q2. So Q2B. The third incoming is A, that is Q3A. So mark it as number 2, right? So next we have Q3's equation. So we have only one incoming towards Q3, and that is Q2A. Mark this equation number 3. Now you have to make this equation Arden's equation, so that it can be replaced with its unique solution written by QP star. R is equals to QP star. R is equal to Q plus RP. Its unique solution is R is equals to QP star, right? So after this, now I'm going to put this Q3's value into this Q2. What I'm going to do, put the value of Q3 in number 2. What you will get, it will becomes Q2 is equals to Q1A plus Q2B plus, from this Q3 you will have Q2A and this A as such, right? So I will get this equation. After this, if you take Q2 as a common, so Q2 will be taken as a common term. What is left inside? B plus AA, right? If you take Q2 from these two terms, what is left inside? B plus AA. So now compare this equation, compare this equation with your Arden's theorem's main equation, right? So I'm going to compare it with our main Arden's equation. This is your R. This complete thing is Q. This thing is R, and this thing is P. It means that your Arden's will be applicable, which says that R, the value of R is Q2 is equals to QP. So here you need to write Q1A, P's value is B plus AA star. So this is your R is equals to QP star, right? So this is the value for Q2. Next, now put this value of Q2 in equation number 1. Put this value of Q2 in equation number 1. So let's put this value of Q2 in number 1 equation. Your equation becomes Q1 is equals to Q1A plus, instead of this Q2, now Q1A B plus AA star, and this B will be written as such, plus null, right? Now check that if there is any term which will be taken as a common. Yes, so Q1 is equals to Q1 will be taken as a common term. What is left inside? A plus A, B plus A bracket close whole star, B, the square bracket will be closed, and this null, right? So why we have included this null? Because of this reason. Because if you don't include null, you can't apply your Arden's theorem. And this point you will have to keep in your mind, that every time whenever we are writing the equation for initial state, you will have to include the null symbol. For initial state, you will have to include the null symbol. So again, compare it with Arden's. This is R, this is again R, this complete thing is P, and this thing is Q. So in Arden's theorem, P can't be null, but Q can be null also, right? So here Arden's will be applicable, and here you need to write it as, again using Arden's, you have to write using Arden's theorem. What you will get? This is your R, Q1 is equals to Q, that is null. This is your Q. Then you have P. P is this. Complete star. So Q1 is equals to null dot P star. So if you remember, we have one identity, that is I3. I3 is null dot R star is equals to R star. So according to identity number I3, null dot R star is equals to R star, right? So what is left? Then you have Q1 is equals to A plus A, B plus A whole star, B square bracket close star. So now here you can see that you have the regular expression which is free from state. So this is the value of Q1, right? Put this value in number 2. Put the value of Q1 which is free from states into Q2, right? So mark this equation as star. So I am deleting this section. So what I am going to do is, now I am putting this value of Q1. I am putting this value of Q1 in star. What you will get? So it will becomes Q2 is equals to A plus A, B plus A star, B square bracket close star, then this expression which is A B plus A star, right? So now you can see that you have Q2 which is free from states. Because why I am doing all this stuff? Because we have to find out the regular expression. So your regular expression should not consist of any state. It should have only terminals, right? It should have only terminals. So your final answer should be in Q3. So now you have seen that your Q2 is free from states. Now put this value into this. Put the value of Q3 into Q3. Put this value of Q2 into number 3 equation. From that you will get your final solution, right? So I am writing my final solution. You just need to attach one A after this complete answer, right? So your Q3 will be A plus A, B plus A star B square bracket close, A B plus A star, and at last you have this A. So this is your answer, your final regular expression obtained by applying Arden's theorem, right?
सर इस केस में सिर्फ Q1
So the second example is, here we have this transition system which is given to you, and 4 states are given. So first of all, you need to write 4 equations, right? For each state you have to write equation. So for Q1 you have to check the incoming arrows. So here you can see that the incoming towards Q1 is this B and this B, right? So this B is approaching from Q2, so you can write Q2B plus this B is approaching from Q3. So next plus Q3B plus null. So null will be additional and it will be added in every case in case of initial states equation. So here you can see that Q1 is acting as a initial state. So that is the reason I have included this null. So next equation for Q2. So this is your Q2 and only one incoming is approaching from Q1. So you can write Q1A. Mark this equation number 2. Then we have Q3, and at Q3 only single edge is coming, at that is 2 from Q1A. So you can write Q1A. Next we have equation for Q4. So equation for Q4 is Q2A, Q3B, and Q4A plus Q4B, right? So a total 4 incomings are there. This can be also, this can also be written as this thing, A and B, right? Or it can be written as A comma B, same thing. So after writing the equations, you have to substitute some values. So because I need the answer in Q1, because Q1 is your final state, I have substituted the value of Q2 and the value of Q3 in 1. After this substitution, you can see that you will get this equation. Q1 is equals to Q1AB plus Q1AB plus null. So when you compare this equation with your Arden's theorem equation, you will get that R is equal to QP star. So by applying Arden's theorem, you will have Q dot P star. So this is your P. It will becomes AB plus AB star. So after that, by applying I3, identity number I3, null dot R star, which is equals to R star. Null dot R star, which is equals to R star. So you are left with only R star, right? So again, you can also apply identity number I5. I5 is R plus R is equals to R. So after applying this I5 upon this, you will get Q1 is equal to AB star. So this is your final answer, right? So example number 3 is, so here you have 3 states, Q1, Q2 and Q3, where Q1 is acting as initial as well as final state, and upon the processing of 0, it is approaching towards itself. Upon the processing of 1, it is going towards Q2. Q2 upon the processing of 0, it is approaching towards Q3, and upon the processing of 1, it is going to itself. A self loop is there, and Q3 upon the processing of 0 comma 1, it is going to itself. So this is the diagram, right? So again, find out the regular expression. The question is find out the regular expression. So here your final answer will be in the form of Q1 plus Q2, because two final states are there. But again, you need to write 3 equations. You need to write 3 equations for this, right? So let me start. Q1 is equals to, again you need to go for incoming arrows. So upon Q1, only one incoming is coming, that is Q1 0 plus null. This is by default, null will be added for initial state. So first equation is Q1 is equals to Q1 0 plus null. Next, Q2, the equation for Q2. So two incomings are there for Q2. The first is from Q1A plus Q21. Mark this equation as number 2. Then we have Q3. So 3 incoming arrows are there. The one is from Q2. So here you need to write Q20 plus Q30 plus Q31. So mark this equation as number 3, right? So these are the three equations, but your final answer will be of the form of Q1 plus Q2, right? So let me write the equation Q1 and try to solve it. So Q1 is equals to Q10 plus null. So let me compare this equation with, your original equation, which is written as Q is equal, R is equals to Q plus RP, right? So when you compare it, this is your R, P and Q. So here you can easily apply the Arden's theorem. So here you need to write by using Arden's theorem, what you will get, Q1, that is your R, Q dot P star. So here P is 0, so 0 star. So again, here you need to apply I3. Why I am applying I3? Because you can't include null in your regular expression. So here you need to apply by using I3, which is null dot R star is equals to R star. You will get Q1 is equals to 0 star. So here you will have the equation of Q1 is equals to 0 star. The only regular expression is there, right? Secondly, here you have to solve the equation for Q2. So put this value of Q1 in number 2. Put the value of Q1 in number 2. What you will get? Put Q1 in second equation. You will get Q2 is equals to, instead of this Q1, now you have to write 0 star 1 plus Q2 1. Now again compare this equation. Again compare it with your Arden's. So this is your R, this thing is Q, R and P. So again using Arden's, theorem, what you will get, Q2, which is equals to R. This is your R. So Q2, then you have Q. The value of Q is 0 star 1. This is your Q. Then you have P. P's value is 1 star. So here you can find that Q2 will consist of terminals only, right? So you have find the value of Q1. You have found the value of Q2. Now just club it, right? So what you will get? So Q1 plus Q2, which is equals to 0 star plus 0 star 1 1 star. So try to reduce it, right? So if I am taking 0 star as a common term, what is left inside? Null plus 1 1 star. If you take 0 star as a common, null will be left inside plus 1 1 star. So this is your I9. I9 is null dot, null plus R star is equals to R stars. This is your I9 identity, which we have covered yesterday. I9. So now applying I9 over here. So what you will get? 0 star 1 star. So this is your solution, because here you have two final states, q1 plus q2. So your answer will be 0 star 1 star, right? So let me start with the next topic, and the name of the next topic is finite automata and regular expression. Finite automata and regular expression. So in this finite automata and regular expression, right? So in this, a regular expression is given to you, right? In Arden's theorem, we did that. In Arden's theorem, we did that. A diagram is given, and from the diagram, you are finding the regular expression, right? But in case of finite automata and regular expression, a regular expression is given to you, and you will have to draw the diagram. That is, you will have to draw the finite automata, right? So it's the reverse process of Arden's theorem. So for this, you will have to remember three rules. So what are those rules? Rule number one is, whenever P plus Q is given to you, whenever the expression of the form of P plus Q, so its corresponding diagram will be drawn like this. So we have P, we have Q, and one state, initial state, second state, final state. So you have two ways. Plus means, basically plus means or. So I have two ways to go to the final state. The one is with P edge and another one is with Q edge, right? So this is the rule for plus or. If one more regular, here P and Q are the regular expressions. If one more regular expression will be added, let's suppose R, P plus Q plus R, one more edge will be drawn like this with R as a input, right? So you have number of ways for going to the final state, P, R, Q. So this is for plus. The second rule is for dot, P dot Q. This is your AND, which means that you have only one way to go to the final state, right? So what will be the corresponding diagram? So your initial state, then first edge P, one intermediate state have been introduced, then R, oh sorry, Q, and your final state, right? So you have only one way for approaching to final state. So here you have multiple ways, one, two, three, but here you have one way. Suppose if one more regular expression will be written like P dot Q dot R, so one more edge will be introduced like this, and the next state will be marked as final state, right? So P dot Q dot R, right? So these are the two rules. One more rule is there. P star. The third rule is for iteration. The third rule is meant for the iteration, that is P star. So for this, initial and final state will be single state and with PH. P star. P star means initial and final with the edge P. So these are the three rules which we are going to apply under this concept: finite, automata, and regular expression, right? So the question is, convert the following regular expression to finite automata. The question is, convert the following RE means regular expression to finite automata. Here you need to draw the DFA, right? So this is the question which is given to you, and the expression is 0 plus 1 whole star, 0 0 plus 1 1 bracket close, 0 plus 1 whole star. So this is the expression which is given to you. So 0 plus 1 whole star, 0 0 plus 1 1, 0 plus 1 whole star. So this expression is given to you and you will have to draw the finite automata, right? So step number 1. First of all, this complete regular expression will be represented with two states only, right? So I am representing this complete regular expression with two states: 0 plus 1 star, 0 0 plus 1 1. The one state is acting as initial and the another one is acting as final state, right? So the entire regular expression will be written with two states. So this is your step number 1. After that, step number 2. So now bifurcate the expression. So here you can write it as, this is your R1, this is R2, and this is R3. So first of all, see very carefully that which rule will be applicable first. So here you can see that you have to apply rule number 2, that is the dot product. This is the dot product. So I am going to apply rule number 2 first. Here you need to write using R2. R2 is P plus Q. So here P and Q are the two regular expressions. So R2 means rule number 2, right? So according to rule number 2, so your diagram will be look like 0 plus 1 star, a state will be there, 0 0 plus 1 1 1 1, a state will be there, then this will be acting as your final state, 0 plus 1 star. So after applying rule number 2, your diagram will look like this, right? So next, Now again check that which rule we have to apply. So I'm going to apply 0 0 plus 1 1. That is the first rule. Step number 3, using R. So this is sorry. This is your P dot Q. In second step, rule number 2 is for dot product. P dot Q. And in step number 3, we have using R1, which says that P plus Q. So here you can see that kindly draw this diagram in your notebooks because I am going to remove it. So again you have two ways. The one is with 0 0 and the another one is with 1 1. Here I have applied 0 0 plus 0 0 plus 1 1. So 0 0 plus 1 1 is according to P plus Q. You have two ways for going to next state. So here you have 0 0 1 1, right? So next, step number 4. So next rule is P dot Q, P dot Q. So here you can see that the same rule is applicable. So if you have same rule, you can apply that same rule in single step only, right? So here what I'm going to do is again using R2, which is P dot Q. So it says that P plus 1 star, one state will be introduced between these two. Again one state will be introduced between these two. So here 0 0 1 1, because P dot Q, again P dot Q, and next will be written as such 0 plus 1 star and your final state, right? So P dot Q, P dot Q. So this is your step number 4, right? So now step number 5. So we are left with only iteration, that is 0 plus 1 star, 0 plus 1 star. So same rule will be applicable over here. That is rule number 3. Step number 5, rule number 3 will be applicable, which is for P star. So here you will have to write this null, and this 0 plus 1 will be written as 0 comma 1. I'm repeating it again. Whenever you have 0 plus 1, it will be written as, first of all, a null will be introduced. Initial state, a null will be introduced, and you have a loop. For loop, you have 0, and you can write it as 1. Or you can also write it as 0 comma 1. 0 comma 1, and the remaining diagram is same. 0 1 1, a state. Next again a null will be there, because again here you have to remove 0 plus 1, and 0 plus 1 will return as 0 comma 1, right? So here whenever you have the iteration 0 plus 1 star, it will be removed by introducing a null. First of all, a null will be introduced, then it will be removed later on. I will let you know how it will be removed. So here I have applied rule number 3. So next, step number 6. So step number 6 says, I'm going to apply step 6 in this only. So how you can remove it? Simply by placing this state to this state, right? Because this is the edge having null as an input. So I am removing it. How I can remove this? Simply, so this is step number 6. The heading is removal of null. Removal of null. So it will be acting as your initial state, and by placing this final state to this, so it becomes final state with 0 comma 1. So here you can see that we have eliminated two states, right? So whenever you will be asked to draw the finite automata, you will have to go for minimum number of states. So here two states are extra with null moves. We have removed those null moves, right? We have removed those null moves. So after this, step number 7th. So after this, step number 7th is you will have to give the names. You will have to, step number 7th is assigning state names to edges. So step number 6 is Q note. It will be written as Q note. Then we have Q1, Q2, and Q3, right? So if the question is convert the following regular expression to transition system, then it will be okay till this point. But if in the exams it will be asked that convert the following RE to finite automata, it means that you will have to make the DFA. So here you can clearly see that upon the processing of 0, Q0 is going to itself and to Q1. This is your NDFA, right? So let me draw the table for this diagram, which is for NDFA. So here the table is states. So how many states are there? 4. Q0 is initial, Q1 intermediate state, Q2 intermediate state, Q3 final state, and two inputs are there 0, 1. So Q0 upon the processing of 0, it is going to itself. So here you need to write Q0, comma, Q0 upon the processing of 0, it is going to Q1 also. So here you can find that this transition table belongs to NDFA because more than one output is coming. Next, Q naught upon the processing of 1, it is going to itself. So Q naught is there, and Q naught upon the processing of 1, it is going to Q2. So again NDFA, multiple states. Next, Q1 upon the processing of 0, Q3, Q1 upon the processing of 1, no state output, dash. Q2 upon the processing of 0, dash. Upon the processing of 1, Q3. Q3 upon the processing of 0 and 1. So here Q3 and Q3. So this is the table for NDFA, right? So you will have to convert this table into DFA's table and then the corresponding transition diagram for it, right? So let me draw the corresponding DFA table. So how a DFA can be drawn? So DFA, so states input 0, input 1. So first of all, every state will be written with the help of square brackets, and you will be starting from the row 1, and row 1 will be written as such, right? But with the help of brackets, q0 comma q1, q0 comma q2. After that, forget about these states, right? And you will have to write those states from the new table which is not written on the left hand side even a single time. So first of all, I'm going to write this q0 comma q1. Again check q0 upon the processing where it goes. Q0 upon the processing of 0, it is going to q0 comma q1. Then q1 upon the processing of 0, q1 upon the processing of 0, it is going to q3. So here q3 will be added. Next, q0 upon the processing of 1, upon the processing of 1, it is going to q0 comma q2, and upon the processing of 1 q1, so it is going to nowhere. So this thing is complete. So I have written it, so it will be written now, that is q0 comma q2, right? Again, q0 upon the processing of 0, q0 q1, q0 comma q1, and q2 upon the processing of 0, nowhere. So completed. Next, q2 upon the processing of 1. First of all, q0 upon the processing of 1, that is q0 comma q2, and q2 upon the processing of 1, that is q3. So this thing has been written, this has been written, this has been written. Now you have to write q0 comma q1 comma q3 and check the processing, right? So q0 q1 q3, q0 upon the processing of 0, q0 comma q1, q1 upon the processing of 0, that is q3, and q3 upon the processing of 0, again q3. So no need to repeat it. So completed. Next, q0 upon the processing of 1, q0 comma q3, q0 comma q2, q1 upon the processing of 1, nowhere. q3 upon the processing of 1, q3. So here q3 will be written, right? So q0 1 3, this has been written, this has been written, but this pair is still pending, that is q0 q2 and q3. So again check for q0 upon 0, q0 comma q1, q2 upon 0, nowhere, q3 upon 0, q3. Next, q0 upon 1, q0 upon 1, q0 comma q2, q2 upon 1, that is q3, and q3 upon 1, again q3. No need to repeat it. So here you can see that all the states which have been written under 0th column and under one input column have been written here once, right? So your table have been completed. After that, q3 is the final state. So in this table, you need to mark all these states where q3 is coming. So these two states will be marked as your final states. So this is the table for DFA. After this, you will have to draw the diagram. So after this, the corresponding diagram, transition diagram for DFA. So let me draw it. So first of all, this initial state, remember this thing, don't forget this square bracket, right? So Q naught upon the processing of 0, it is going to Q naught comma Q1, right? And upon the processing of 1, it is going to Q naught comma Q2, right? So the first row have been completed. Next, Q naught comma Q1 upon the processing of 0, it is going to, this is your final state. So double circle Q naught 1 comma 3 upon this state. Q naught comma Q1 upon the processing of 1, it is going to this state. So these two rows have been completed. Next, turn for Q naught Q2. Q naught Q2 upon the processing of 0, it is going to this state, and upon the processing of 1, it is going to a new state, that is Q naught Q2 Q3 upon the processing of 1, right? So 3 rows have been completed. Next, Q naught 1 3 upon 0, it is going to itself. Upon 0, it is going to itself, and upon 1, it is going to this state. Next, last row, Q naught Q2 Q3 upon the processing of 1, it is going to, upon the processing of 0, it is going to this state, and upon the processing of 1, it is going to itself. So this is the transition diagram for DFA. So your question has been completed. So here you can see that the transition table for DFA and the corresponding transition diagram for DFA, right? So this is done for today.